The last part of these three lessons, 2.9 to 2.11, focuses on how to interpret data and make predictions from data. And there's two ways that could be done when you have data, and you can see here these are higher education costs, public and private schools from 1985 to 2007. There's two ways of handling it when you have situations where the data appears to be mostly linear. You can see that if these are plotted, and depending on the scaling, it may look a little less or more linear, but the scaling, you can see that they're basically following a linear pattern, both of them. There's a little deviation from that. There's two ways of doing that. You could either use a combination of what they would call interpolation or extrapolation, where basically you're using a couple of data points to write the equation of the line and use that to either predict values in between if you don't have a lot of values. Say if a lot of these were missing, that you could say, okay, well, if I didn't have the 1990s data, I could use that equation to predict what it possibly was in 1990. And of course, extrapolation is the same process, except you're going beyond the end of the data. So if I want to go into the future, which is one of the questions you're being asked about this. And the other one is using regression, which is going to be the second part of this. So this first part is going to deal with writing equations to describe data by using two data points in the data. So this demonstration is going to focus on doing that for public college fees. So in this first part here, you're asked to use the data from 1985 to 2000 to determine the equation of a linear function that predicts the cost of attending college, y, given the number of years past 1985x. Again, you see this number of years past 1985, again, to make the values that you have for your x values be a little bit tamer. So what you're seeing here is that these are all becoming the values, 1985 being 0, 2007 being 22, and of course all these in between. And anything that would go beyond that, you'd have to adjust accordingly. We're going to focus on the public data at this point in time. So to write the equation of that using those two values, 1985 to 2000, you're just going to use these as ordered pairs. So you have 0.0, 1045, which would be a y-intercept, and 15, 2562. So calculating the slope, because you need that as part of the equation. Now this slope, and if you make it in decimal form, it's a really nasty looking decimal. The repeating pattern doesn't happen immediately, so just going to leave it in fraction form. But you do have the y-intercept, b, being 1045, so this equation could be y equals 1517 over 15 times x plus 1045. Now, you could use this now to make a prediction of what happens in the year 2022. Now, 2022, with 2007 being 22, you have to realize that's 15 years after that, so x is going to be 37, and you would substitute into this. If it's continuing to follow this general pattern, that would be about $4,786.93. The issue that you sometimes have by picking 2 points in particular is if you pick two other points, and that's what's going on here, you're now asked to do, okay, for 2000 to 2007, let's come up with an equation based on that. Well, if using these data points, again, I'm going to calculate the slope, doing the same way we were used to doing it, you get 1,745 over 7. Again, I'm going to keep that as a fraction. We don't have a y-intercept here, so I'm going to use more of a point slope form to keep integers involved rather than going to decimals and other nasty looking fractions. So I'm just going to have the 1,745 over 7. I'm using the 15, 2,562 points, so I'm going to have x minus 15 in parentheses plus 2,562. If I use that to predict the cost for the year 2022, again, x is 37, and I carry through that calculation, I get that the cost is approximately $8,046.29. So you can see there's quite a bit of difference in predictions depending on which 2 points I chose to come up with that linear pattern. And that's part of the issues that you'll sometimes have with this. Going back to the graph here, which prediction is more accurate? To tell you honestly, you'd probably need more information to know for sure, and it's probably the case that really neither one of them is very accurate. Because going back to changing this to be the number of years past 1985, the first graph looks like this. You can see it's kind of following a lot of the points here, but kind of veers off towards the end. So it's, following fairly well, gets off the beaten path here. So you have some data points that are quite a bit different towards the end here. And that's the prediction you had. Whereas the second one used these 2 points, and you can see here that you have a lot of points that are not falling on that green line, and the latter part is. So that's why you're having quite a bit of difference between these two values. And so that's one of the issues that you'll sometimes have when you're doing linear interpolation or extrapolation. So now you're going to be asked in example 5 to do the same thing with the private school costs. So work on that and see what you see with that.